0.0. 0/1. Do you agree?
Yes.
Then I say to you that the gateways must be assigned the first usable IP address, right? Per network. Again, in network. So if this is a network, right? What is your first usable IP address? 1.1. Are we good?
Yes.
Yes. That means another 1.1. That means here your 0.0/0 it will be 1.1. Are you familiar?
Yes.
You must say funny because that's where the trick is. That's where the trick. That simple knowledge. This is your 0.0. It's an interface, right? That means this is your local area network. Do you agree? How many networks are here? Let's start there. How many networks do we have on the topology? How many networks? Because that's where the trick is. The trick is just simple information that you needed to know and identify and understand. Because I remember there's a question there that I asked you. I gave you a topology, then I asked you how many networks. I think that question only 4 or 3 people got it right. The rest did not number one, they did not, I don't know if they did not understand the question or they did not understand how to identify networks. Let's start today. How many networks are here? If right now you are writing, you are given an opportunity for you to identify, then the question says, how many networks are in the topology?
5.
How many networks?
5.
Yes, 5. Okay, she's saying 3, she's saying 5. I want you to show me your 3, I want you to show me your 5, but let's start with 3. So that if 3 is wrong, then at least 3 will be able to correct herself with 5. If 5 is wrong, then someone else will give the correct answer. We're gonna get. So you're going to start. You cannot keep saying, Madam, how did you identify your 3? Just stand up. To be ready to learn again. And I said, the shyness, the what, because we are intentional this time again. We want the 50%. So, Madam, you want the 50%? That's the only way. I want you to go and show us. How no much anything? Kill it. Eh? No. Oh, guess it. Next time we don't guess it. We understand how we identify things. So what is the saying? Huh? Charles. Changase. Okay, Changase. How did you identify your 5? Show us how did you count your 5? Okay, Emma saw that's how much. Please.
Network 1.
Awesome. Okay.
Network 2.
Mm-hmm.
3. 3.
Yes. So even if I get it right now, it will be easy for you to identify because obviously then you realize sometimes I said to you maybe create 4 subnets, right? But you still don't understand the difference between a subnet and a network. Same thing. That's why we use them interchangeably, right? So we still have a network, we still have a subnet. Subnet is when we say subnet after we have subnetted. I give you an IP address, right? Or a network address. Then I say create 6 subnets. That means from a given network, you are creating others, the sub networks. Does it make sense? A. So now, this is 1. This is your 2. This is your 3. This is your 4. This is your 5. We have 5 networks. So now, when you are here, on your 1.0 network, what is your gateway? Because these are the type of questions that I'm going to ask you. I think I asked you also. What is the gateway for network 1.0? What is a gateway? First, you must understand what is a gateway. Define a gateway. After defining the gateway, you will be able to identify now what is a gateway. What is a gateway? Anyone? Anyone? Gateway? 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 Can I say anyone?
Matlokotsi.
Ma?
Matlokotsi.
Matlokotsi,
It's a pathway from one network to another.
a path from one network to another. You can say that. Another one, you can say it is an interface that allows you to reach remote networks. I want that one. That involves remote networks. It is an interface, a gateway. You can say a gateway, this is an interface. Is an interface that leads to remote networks. In simple way. Simple explanation, simple definition. What is a gateway? A gateway, it is an interface that leads to remote networks. Or a gateway, or it is a way or a path or a route that leads to remote networks. Either you use gateway, either you use a route, either you use an interface, we are speaking about the same thing. It is this. This is your gateway. If you are in this network, this is your gateway. It leads to remote networks, because if you are here, this is remote to this. If you are here, remote, it means it is far from this. Remote means that for me to get there, there are certain measures that need to be in place for me to get there. Remote, it is outside of my current location. That means it is remote to me. It is outside of my current position or current location. So now, when we are here, when we talk about a gateway, we talk about this interface. And remember, I can ask you which networks can have gateways. Which type of networks? Remember, we have type of networks. Yeah? We have local area networks. We have wide area networks. I get ahead. So, which type of network can have gateways? Local area networks. Local area networks. So now, if we are here, 4.0 network, what is the gateway?
0/2.
Huh?
0/2.
0/2, which is this point. When you are here, it's going to be this point. Why? Because there's no way, if PC3 wants to communicate with PC2, there's no way that can happen without a gateway. There's no way that can happen without a gateway. For PC3 to be able to communicate with a remote network like 4.0 and 1.1 and others, you need a gateway. Like I said, a gateway is like a door leading to remote networks. So when I'm here, what is the door? It's going to be this. Or I want to go and speak to someone in 131. What is the first thing that I'm going to do? I'm going to get up and I'm going to use that door to. For me, there's no way that we can reach 131 without that door. Does it make sense? There's no way. How another way? The only way to reach 131 is if we get out of that door. That means from where we are, 131 is remote to us. So the only way to get there, for me to be able to speak to someone who is in 131, I must go to 131. And for me to get to reach 131, I need to use a door. And that door, that is that door. It is your gateway. Get a gateway to a remote network. Does it make sense? But if ever we are on the same network, like now, we are on the same level, and I want to talk to her, I don't need a gateway for that. We are in the same venue, same location, same area. I don't need a gateway for that. That means this is our local area network. For us to communicate, we don't need a gateway. That's why if it's like this, another PC here, PC4. For PC3 and PC4 to communicate, what do they need? What will they need? I can ask you, in your understanding, PC3 wants to communicate with PC1. They also want to communicate with PC4. What are they going to, what will PC3 need to achieve this? To be able to communicate with PC1 and PC4. So your answer must state, PC3 to communicate with PC1, they are going to need an IP address and a gateway. And static routing, 3 things. Because for this syllabus, I only taught you guys static routing. They are going to need, for Mzanamo, to communicate, Lemuto, Kapa Lemuto, they are going to need 3 things. They are going to need, number 1, the IP address of the destination or where they are going. Number 2, they are going to need a gateway, a way to go to that network. Number 3, they are going to need that static routing. But the thing about static routing is that you configure static routing whole routing as a PC. And the question says, what will PC3 need? So what you do to PC3, when you enter, and you're going to enter what? The destination IP address man OCMD again. Destination IP address and what else do you need? A gateway. But for PC4, for PC3 to talk to PC4, you only need
IP address.
the what? Oh, I get the idea with people go away. Hey, if PC3 wants to communicate with PC4, maybe it's time for you to open packages and actually test it. For PC3 to communicate with PC4, yes, you're going to give them an IP address, but they don't need it to communicate. They communicate by MAC address. MAC, MAC address. Locally, we communicate by MAC addresses. That's why they will tell you, switch. What's happening is that switch does not store IP addresses. Switch store MAC addresses in its MAC addressing table. The reason why the frame is not even going to reach here. From here Because of MAC addressing. Because these two, they are already connected to this. I can make S1, S1, S2, S3. PC3 and PC4, they are already connected to to switch 3 again. That means that they are already on the MAC address table. So now, this guy will be sending a frame to PC or to switch 3. Switch 3 is going to go to its MAC address table and check for it. What is the MAC address of this specific IP address? I get a PC4 in the IP address. Switch 1 is going to check for the MAC address of that. Then it's going to check on its table. Oh, the person is here. Then it's going to forward it. It's going to forward the message. That means from here, Itamo is that. That's why I say it does not need a gateway. Does it make sense?
Yes.
Hey, so hi Kwamo, if you're going to communicate with this person, hi Kwamo, or Uno checker the MAC address table, the MAC address table that way. As man now we know the PC that is linked, I mean the destination IP address is actually removed to me. Because the MAC address table in a site, yeah, the PC, yeah, the IP address, then another site, the MAC address is linking to each IP address. So Mzala is going to see, oh, this person is not directly connected to me. This is a remote IP address. Therefore, it's going to forward. In fact, it's not even going to forward, it's going to distribute the frame, putting active, except where it came from. It came from this, again, from this port. So now it's going to distribute it to this port and this port. This port is going to reject it because it's still remote. But this one is going to accept it. Because this one, remember the table here, what is the name of the router? Where does the router store its IP addresses? Your routing table. Routers store IP addresses on what we call a routing table. Which command are we going to use for us to view the routing table? Which command? And on which mode? You might have privilege and say IP route. It's a good people. IP route. The minute you go to your privilege mode and you type IP space route, your routing table, the routing table of that specific router is going to appear. So, do you understand?
Yes.
Now that we understand, let's talk. Okay.
That part of PC3 communicating to PC1,
Mm-hmm.
you said something about the CMD not arranged that part.
Oh, I get it. If ever you want to test for connectivity, where do you go? You go to the command line interface, the CMD. I get it. You go to start computing, and you type CMD. But on the packet tracer, you go to command line, man. The black screen. Hey, you're on a CMD. You go there. Once you are there, you're going to say ping again. Hey, you're going to say ping and the name of the IP address that you want to ping. Again, yes. Then it's going to give you the replies. If it's reachable, it's going to give you the replies again. Hey, if not, it will return something. No reply. Something I can't remember what it returns. Like people.
Yes.
Hey. So when you work at CMD and for you will have to go to the CMD on your packet tracer. Then how far more you're going to ping to the destination IP address to check if the person is reachable or not. If they are remote and you did not configure certain routing, obviously they're not going to be reachable. Does it make sense to the point? Okay, if you say you understand, I'm going to ask you a question. All right. Question is, PC1, I'm going to ask you, PC1 wants to communicate, want to send a message to interface gigabit 01, right? And it returns, okay. PC1 can reach, simple question. PC1 can reach gigabit 01, but it cannot reach gigabit 00 on the same network of 2.0. What could be the error formats? If you say you are, then the test that you're going to write, I'm going to play around these things. Because the lecturing different things, also in the questions are high. You know, there are chapter 1 and chapter 2, chapter 3, and everything practical. So I'm telling you now, I will be playing with you. Hence, I'm saying you must understand. PC1 tried to reach gigabit 01, and it was successful. However, when PC1 wants to reach gigabit 00, it gave an error, or it did not give any reply. Why is that? They are the same network. PC, gigabit 01 and gigabit 00. It gave an error. Come.
I'm trying.
Oh yeah, we are yet to do exactly that.
As much as the second interface for the 2.0 network, it was under the same network, but it was under a different router.
Yes.
So something is a configured very good POE. Like the PC1 has to be with the router.
So what is the solution? Okay, the problem you have identified, ne? I want you to listen ne, what she's saying. I'm going to say what she said, but in our language, in our networking language. So you must hear. It's the same thing as what she's saying. She's saying that in as much as gigabit 01 and 00, they fall under the same network. The thing is, the other one belongs to this router, the other one belongs to the other router. Therefore, in simple terms, what she's saying is that in as much as gigabit 01 and 00, they fall under the same network. However, 01 is directly connected to R1, which is directly connected to this network at 1.0, which PC1 belongs to. Does it make sense? Yes. This part A, this one, that in simple terms is that 01 is directly connected to R1, R1, R2, R3. Gigabit 01 is directly connected to R1. And 00 is directly connected to R1. That's why, remember, what is the gateway for this one? What is the gateway here? Okay? Exactly. The gateway for this is going to be gigabit 0, 0. Yes. Your face, Shannon, your face is wrong. Yeah. Which is 1.1. In IP addresses, this is 1.1 again. Hey, this is when you're 1.1. Which is this? That means here is going to be 1.1. But in terms of interface, which is what we're talking about right now, is 0, 0. Is 0/0. Does it make sense?
Yes.
Are you following?
Yes.
So now, we were saying that gigabit 01 is directly connected to R1. But gigabit 0/0 is remote to this. Why is in simple answer. Gigabit 01 is directly connected to R1, same as this network. Or you can say this network, this interface belongs to 1.0 network. Simple. Your answer, this belongs to this. That's why this can reach this, because they are the same network. They're on the same network. That's why they can reach one another. But this one, the minute they try to reach this one, they are no longer directly connected. This is not directly connected to this, but it's directly connected to this. Though they belong to the same network. Does it make sense?
Yes.
Hey. That means the minute this person wants to reach this one is now removed. That's where now we talk about static routing. Does it make sense?
Yes, ma'am.
How do we have the routing here? Okay. PC1 now wants to communicate with PC4. Which static routing are we going to configure? I guess by now we know. For you to reach remote networks, you can reach them in two ways, either statically or dynamically, right? Dynamically, we did not do that. We're going to do that second semester. We do static routing statically, right? So my question is, which static routing are we going to configure? Let's start with R1. Remember, PC1 wants to continue PC4. Which static routing are we going to configure on R1? Just remember, guy wants to communicate with this guy. Ne? For this person to communicate, that means the root and it's still directly connected. And we already discovered that this one is remote to this, but this network is directly connected to this. Okay. Which networks do we currently have? Which networks do we currently have in our networks? Network addresses.
1.0
1.0 and
2.0.
awesome. Yes. Come on.
2.0
Yes. Come on.
3.0.
Come on, Kima.
2.0 and 4.0.
Yes. Come on, D3. Come on, debate. Kids, Awesome. So if you can identify that, then why look for the static routing? It's exactly the same. That means this guy wants to communicate with this guy, ne? But routing near high, they will have to pass 2.0. Again, they will have to pass 4.0. They will have to pass 3.0. They will have to pass 5.0. Again, and in those routes that they must pass, they don't have them. Come on. Go R1. R1 haina 3.0, haina 4.0, haina 5.0. So that means haina the route. So it can be the route it must pass, it's not there in R1. So static routing says that I want to configure the route that I'm missing for me to be able to reach my destination. So that means R1. In R1, you are going to configure 3.0, 4.0, and 5.0 as your static routing. Does it make sense? My man, I get it. We move from here. And once we are here, we agree that we have 1.0 and 2.0.
Yes.
But the routing here, we have 5.0. If 5.0 is not in here, it's going to drop the packet. It's not going to pass because there's no route that leads to the destination. The packet is going to be dropped. That means the packet the packet is going to be dropped if you don't have 5.0. Even if you can have 5.0, but high more is going to be stuck because like how 5.0 and yes, and even if you don't 3.0 again, even if you can configure 5.0, but here more it's going to be dropped. How 3.0? Does it make sense? Yes. So that means all the routes that lead to destination, we need them. If they are not in here, we need them in here. Every route that we are going to pass through, leading to the destination, we need them in R1. Then, we have R2. R2 is 2.0, 4.0, 3.0. But higher 1.0, higher 4.0, you cannot communicate with someone you don't know. So that's why the static route that is missing in R2 is R1, is 1.0 and 5.0. Because already 2.0, the 4.0, 3.0, they are directly connected. They are not needed. Already they are there. So what is not there is 1.0 and 5.0. So you are going to configure two static routing, 1.0 and 5.0. Here with the whole R3. R3 only have 3.0 and 5.0. You are going to configure 4.0, 2.0, 1.0. Does it make sense? Yes. So now we come, now that we know which static routing tool to configure, there comes now the what? The next hop IP address. The next hop IP address. We are here. And where are we going? We are going that side. Yes. We are going that side because we are on 5.0. If and when you talk about the next hop, you talk about the next router, basically. So now, when we are here, what is your next hop IP address? Let's say here is 2.1 is 2.2. Here is 3.1 is 3.2. Yes. Multi 4.1, multi 5.1. When you are here, what is your next top IP address? It's 2.2 level. It's next hop, it's the next router. The next router. So static routing, how to configure? I didn't give the command IP route guy on the global configuration mode. Remember that. On the global configuration mode, you say what? You say IP route, then you say the network address that you want to configure, right? R1, we want to configure 3.0. Go to IP route space. Go to 192.168.3.0 space. We are going to say the subnet mask. Let's say we are using default subnet mask for class C. So that's 24. After we say 192.168.3.0, we see the subnet mask, which is 255.255.255.0 again. Then it was the next top IP address, which is going to be 192.168.2.2. Ufumana Tremax yaha. Say if you are configuring 5.0, say that means every static routing, say R1, is at the same next top IP address. 2.2. I have to change. Who change the network address? We are configuring 3.0, 4.0, and 5.0. The only difference is the network address, not the next top IP address. Once you are here, now we go to R2. Which static routing are we going to configure? R2. Which is where now the trick is. Because R2 is a middle router. It's like a decider, this one. So number one, which static routing are you going to configure in R2? Let's try to identify them. Which IP address, which network addresses? Yes, we are going to configure 1.0 and because now that means it decided. That means if you come from this side, go in that side. You are from 5.0, you are going to 1.0 again. We are from 1.0, you are going to 5.0 again. That means those are two different next hop IP addresses. If you are here, you are going that side. How will you move? What is your next hop IP address? Awesome. 3.1. Yes. So that means your route, which is 1.0, that you're going to configure in here, is going to need the static routing. Again, star 1.0. But the next hop IP address is 3.1. Yes. When you are this side, going this side, again, we are here. We are going this side, 5.0. That means the network address is 5.0, right? The next hop IP address is yes. So when you are here, you are still here, but you are going this side. You want to reach That means the network address is 1.0. The next hop IP address is yes. Once you just understand the topology, I believe you in me. All the answers you can get them right there. Does it make sense? Yes. Who doesn't understand? So that means we are done with static routing. Give us who has questions, yes.
On the previous task, there was this question which wanted us to explain which static routes are we going to configure. I didn't get how we're supposed to explain that.
Explaining is like identifying. Okay, fine. From this, if I say explain which static routing are you going to configure for PC1 to be able to reach PC4, you explain. Since PC1 wants to communicate with PC4, in R1, the static routing that you're going to need is this and this and this. In R2, you're going to need, you are explaining. So when someone reads your information, either even those who just identify them, I gave them correctly. The most important thing is for you to identify the static routing correctly. Okay, now that I'm communicating with PC3. In PC1, I'm going to need this static routing. In PC3, in PC2, this static routing. In PC3, this one. Now you are explaining. When someone reads your explanation, they will be able to understand. Does it make sense?
Yes.
Any questions? Any questions, Mamajas? What's your name? Okay, anything that you want us to deal with here? Are we good, guys, to the routing? If you still don't understand, you remember you can make an appointment. Kind of when you're writing lecture over here. That means you still have this week to make an appointment just for me to assist you if you're still lost. Yes?
Ma'am, could you please let it in the maybe if okay this announcement here the notes on how to answer the question is mostly the marks tengata mara e be le potso e bonang ka re batla karabo e one fela.
Okay, can you open your test and just give me one of those questions? Open a test, open your test, give me one of those questions so that we answer that one question. And in most cases, you will realize that that question that has more marks, it's either you are explaining or it needs you to understand something. Like for instance, that question, 5 networks. It's just a number, 5 networks. But I think it was 3 marks, if not 4. Because you can't get it right if you don't understand. So all the questions that need your understanding, in most cases, they have more marks. So I can never give 3 marks about 4 marks to true or false. Because key guesswork, you can guess it and get it right. But if man 5 networks, you must understand it for you to get to the 5. Does it make sense? Yes. A. So just the answer is just a smaller thing, but we get 6 marks. Because it needed you to understand a specific concept for you to get to the right answer. So that means my marks also include not only the correct answer, but even the understanding behind the correct answer is marks with me. Just one question that you did not understand, so we tackle it. Hmm?
It's wrong. Once a username and the password for a lockdown browser.
You want?
When we open the we are going to enter.
Oh, dot. Forward back. A backslash user.
And password.
I think the password. View on the one. Lockdown browser. Oh yeah, who? Your last password to your user. Username if username.
Tungena ku view submission. Then angeke view the phone. Kofu kuba ku iPhone phone.
Dot.
Download it local browser.
Give me one forward. This is to use over the end.
iPhone.
Why does it need lockdown browser but you have already accessed it? Also,